3.6 Model direct variation. Vocabulary. The word or words direct variation just means two variables, x and y, that show direct variation. Provided by y equals ax, where a does not equal to 0. The non-zero number a is what we call the constant of variation, and y is said to vary directly with x. So here we have examples. Y equals 5x. That's a direct variation. 2x minus 3y equals 0 is also a direct variation. As you can see, it follows this format, y equals ax. However, y equals x plus 5 is not a direct variation. It does not follow y equals ax. And the same goes for negative x plus y equal to 4. If we change this to slope-intercept form, we have this extra constant to the right that makes it not a direct variation. So let's summarize the properties of graphs of direct variation equations. The graph of a direct variation equation is a line through the origin. The slope of the graph of y equals ax is a. So remember, this is called the constant of variation. So when a is positive, the slope will be rising. If a is negative, the slope would be, or the constant of variation would be falling or negative. Let's practice what this concept is all about. Part A, tell whether the equation represents direct variation. So all you have to write is y for yes and for no. If so, identify the constant of variation. Okay, so y equals 2x. So this follows y equals ax. We want to say that yes, it's a direct variation. And the constant will be 2. And this one, y equals negative 3x minus 2. Obviously, it doesn't follow the direct variation model because of the negative 2. We write no. And for this one, y equals 65 over 13x. So y equals 5x. So we want to say that yes. Part B, graph the direct variation equation. So we can just rewrite this as y equals to 5/4 x. You know that for a direct variation, it goes through the origin 0, 0. And we can simply use another point, say 4, when x is 4, y is 5. It's about right here. This would be 4, 5, 0, 0. And we can draw a line. And for this next one, y will equal to 2.25x, and we know it goes through this origin. And I can find another point. Maybe I'll just use a simple point such as 1. When x is 1, y is 2.25. Here. And I can connect my dots or my points. Part C. The graph of a direct variation equation is shown. Write the direct variation equation. Then find the value of y when x equals to 10. So we can go ahead and take y equals ax, and you're given a point. Substitute the point into this direct variation model. And here let's begin with -3. And set it equal to a -5, 8 times -5. So a will equal to 3/5. And rewrite the equation and substitute in a for 3/5x, and that will be part of our answer. That's the direct variation equation. And then find the value of y when x equals to 10. So I just have to substitute in 10 for x here. So y equals 3/5 times 10. Y equals to 6. Okay, another type of direct variation problem. Part D, tell whether the table represents direct variation. So again, you have to write yes or no. If so, write the direct variation equation. To determine whether this table represents a direct variation, we need to find out whether all the pairs of numbers have the same ratio. So 12 subtract 6 is 6, 2 subtract 1 is 1, 18 subtract 12, 6, this is all 1. So apparently they have the same ratio of 6, so this is your constant of variation. And yes, it's a direct variation, and we will write y equal to 6x. And for the next one, this would be -12 subtract 6 is -18. -4 subtract 8 is -12, and then so the constant will be what? -18/12. 3/4. And if we take the difference of 0.5 and -12, put it over 96, subtract -4, we get 12.5 over 100. And if we simplify this, we know that's not going to equal to 3/4. So, no. Part E. Given that y varies directly with x, use the specified values to write a direct variation equation that relates x and y. So again, y equals to ax, y is 26, x is 13, a is 2, so therefore y equals to 2x. Okay, let's look at this word problem. To use low voltage lighting, you need a transformer to control the flow of electricity. The table shows the size S of transformer in watts needed for the number N of 12-watt lights you want to use. Okay? Explain why S varies directly with N. Okay, first we need to check the ratio, the constant of variation between S and N. So I know S would equal to AN. S would be your Y here, and N would be your X. Okay, so 6 subtract 4 is 2, 72 subtract 48 is 24. Same thing between 96 and 72, it's also 24. So as you can see, the constant of variation is 12, so S equal to 12N. So we could say the ratio of each data pair is 12 for part A. And for part B, Write a direct variation equation that relates S and N. So I already did that for you. S equals to 12N. C, how many 12-watt lights can you install using a 225-watt transformer? So here, this would be our S. And we need to find out N. N would equal to 225 over 12, and that is about 18 and 9 over 12, but we cannot have 9 over 12 of a light bulb or light. So we can go ahead and just take it out and say we need 18 lights. And that concludes our lesson.